What we're gonna say is we're gonna create a new user equals user, and the name is gonna be the name. So the name in here, I can do something username, so you can see what. So this should be the username, for instance, and the age equal age. And what we want to do after is just gonna be db.session.add new user. So we add a new user, and after we commit session.commit, and we can return in here that user with name is added to the database, to Postgres. That's it for now. Oh, sorry. What else do we need? Now we have to do some kind of error handling. So what happens if the user is already in there? Now usually this is gonna return a server error, or you can do some kind of error handling yourself, either with try and catch or with if statements. For instance, let's say we have the user and we say that if user name equals username, so we try to find if the user is already in the database, and first, so we just return a record. We're just gonna say return user already in the database, and as a status code 409. Perfect. Okay, let's try again in here. So we're gonna also, the docker compose, you can run it in one line. So we can say right docker compose down and docker compose up. So this is gonna run the one after the other. You can do that. All right, so we can see the service database started in here. Now in order to test that our service works fine, I will create, I'm gonna do some API calls to see if that works as expected. Perfect, our both services are up. Okay, so as you see, it works. Now we want to test the user endpoint. Now if we go right now to users, this should return an empty list because our database is empty at the moment. Perfect, so that means that it works fine. So it goes in here and returns an empty list. Now let's add some records in there. How to do a request? What we want to do is to import the request library. I'm gonna say new request equals request.post, because we want to post. Now the URL, let me build the URL in here. URL, post URL, let's say, is gonna be http localhost port 5000 and users, and we're gonna send a JSON in the body. So we're gonna say new user equals. Now this should match what the web server should accept, right? So we should, because we say data request.json and we get the name and the age, so we should send a name and an age in our API. So this should be, for instance, name should be John and age would be 15, for example. And what we're gonna do is post URL and JSON equals new user. and we're gonna print the new request. Now the response we're gonna receive if it's added. So if it's wrong, we're gonna receive this. If the user is already in the database, we're gonna receive this error. We're gonna receive the response. If it's correct, we're gonna receive this. So in order to receive that, we're gonna print the text. Let's see, Python make request. Perfect. So that means that it's added. Now, if I want to print, if I'm gonna run it again, response 409, because so it added it in the first time, but in the second time I tried to add it, it got into here, it found that it's already added, and return this response. Let's see if it's, let's send right now a get request to return all the users, and it's here, and it seems to work perfectly fine. Now, if we want to add multiple users, maybe we can create users list. We're gonna create a list of dictionaries. So we're gonna say Michael, Maria, and Helen. And we're just gonna go and say for user in users list. So we're just looping through the users list in here. What we want to do is make an API call. I feel my camera is not stable. Hopefully it is, we'll see afterwards. And here is gonna be user, because what we do is just loop through the dictionary. So every time we set up, this is gonna loop through the list of dictionaries, and we're gonna print the response, the text, because actually it's gonna, otherwise it's just gonna send us the status code. Let's see. Perfect. So that means that all of them were added. Let's see, enter, and it seems to work. Last step, we can add a new endpoint which is gonna delete a user. So what we're gonna say is app.root. We can either add it in here or add it as a new endpoint. So I'm gonna add it as a new endpoint so you will see that as well, how it works. In here, and this is gonna be command username, or actually name, it's not username, name. And after we're gonna say def remove user, and we're gonna say that the methods here is gonna be delete. So this is gonna accept the delete method, and we're gonna say if request command dot method equals delete, which is gonna be delete because this is the only permitted method at the moment. What we want this to do is, first, a good check would be to actually try to find if the user actually exists in the database. So we can say user equals user.query dot filter command by username. Sorry, why username all this time? This is name. Names equal name dot first. Okay, yeah, I have to add it in here as well. and we're gonna say if user, so if the user exists, we're gonna say db.session.delete. So you see what is the point of SQL Alchemy. Instead of writing a query to say delete from where name equals that, SQL Alchemy is a way to interact in this way. db.session.commit, and we're gonna say return user with name has been deleted from Postgres. Is our server still running? Yes, it is. So let's try to do a delete request. We're gonna go on the make requests. We're gonna say that right now, let me comment all of this, and we can say import requests. It's gonna be delete request, delete URL, for instance. We can say that it's gonna be HTTP localhost port 5000 users and the name of the user. So right now this is what we're gonna pass as a parameter. Now let's say I want to delete Mike, right, and we're gonna say new delete request equals request dot delete URL, and I'm gonna print the new delete request dot text. Okay, we received the response. Let's refresh and do a get request in here. Perfect. So as you see, the user Mike has been deleted from here. Now, if you want to do better error handling and everything, possibly you can add some things. For instance, if you wanted, you could do something like try in here, and if this didn't work, you can say accept and do rollback. So we can improve the error handling, because right now what's gonna happen is you can receive a 200 response even if the response is not supposed to be 200. For instance, right now in here, the only reason that we receive 409 if the user is already in the request is because we returned the 409. So maybe we can improve the error handling later. But this is the basic concept. Get some user, post some, add some new users and delete some users. Maybe we should add a way to update the user, but I'm not gonna spend too much time on that. Now, the last thing that we described in here is, as you see in here, right? Our web server. Okay, web server is still running. So if we do docker compose down and we go docker compose up again, and I'm gonna try to refresh the users. Okay, we have to wait a little bit of time. Now it's listening. You see it's empty, and it is empty because of the reason we explained before with the volumes. Now, in order to avoid having this issue, I'm gonna use a bind mount again instead of volume. So the main difference, it's not so different. So the volume is just, it's gonna save it somewhere else, and it's more persistent, while here it's just synchronized with the host. So what we're gonna add in here is gonna say volumes, and we're gonna say Postgres data. So this is gonna create a folder for us, and we gonna need to mount it on this specific path. So this path is, we have to use this path because what happens is when the Postgres image spins up this image, spins up the container, all the data that are saved in the database inside the container, it saves them inside this path. So what we have done in here right now is we mount an empty folder inside the specific path in the container, and so initially it's gonna be empty, or whatever it's the initial is gonna be empty, but as long as the image, when it's building, it starts saving data in there in the initial build, and when we save new data, it's gonna save them inside this path. Then it's gonna also save them on the path of the host, and as long as this file, I'm not gonna delete this folder on my host, this is some kind of persistence that we keep the data, we keep the data saved. So let's see how it works. Docker PS, perfect. So again, we're gonna go in here and make some requests. Okay. Maybe I should separate them in a different, anyway. I'm gonna say Python make requests. This added back all of these users. Now, if we go, oh, right, okay. I made a mistake, I think. So I didn't do Docker compose down and up. Docker compose down and Docker compose up. Okay, yeah, now it works. So as you see, when you make any change in the Docker compose file, you have to do down and up, otherwise it's not gonna pick your change. Now, alright, so this is gonna be empty again. Okay, perfect. Now we're gonna say Python make request. It's gonna add our users in here, and now as you see, this is where it's saved. And if I don't delete that, let's say I want to do Docker compose down, perfect. All right, so after we're gonna say Docker compose up, seven seconds ago, let's see, and it's here. And the reason it's here is because it mounts this users that we've added in the previous step, that it's already saved in this folder in here, and it mounts it inside the Docker, inside the container. And that's it for now, and let's proceed with the React part.